Thank you for joining this session. My name is Peter Riali. I am a Senior Solutions Engineer at Couchbase. The topic of this presentation is Geospatial Search made easy through the power of full-text search. The focus of this session is going to very much be hands-on and how-to. Essentially, what we're going to be doing here, we're going to describe what our problem is. We're going to talk about the data sources and how we're going to acquire the data to solve our problem. And then I'm going to show you how to build a full-text search index. And then we're going to do some queries and some testing to prove to it that we have it right. So away we go. The problem here is that I really would like a cup of coffee. I just landed at LAX. I've got my little application, and I wish it would tell me where I could find a cup of coffee. And you know, my favorite coffee chain, let's call it Ishmael's, doesn't necessarily have a very good app to tell me where to find my coffee. So in order for us to solve that problem, we're, of course, as in most problems in the data world, first going to talk about what kind of data is available to us. And then we're going to talk about how easy it is to get it into Couchbase. So let's start with our coffee shops. I've got a little CSV here. And it's got a whole list of coffee shops in the Ishmael's chain in California. And it includes a latitude and a longitude for each of them. And what I want to do is get these shops into Couchbase to do something with them. So let's go to our Couchbase server. I'm using the travel sample application, which you guys have seen a million times probably. I did create a couple of new scopes. I created a coffee scope, which is where our coffee shops are going to go. And I created a boundary scope. This is going to be where we put our airport boundaries so that when we can do a proper search, depending on what airport we land in, right? So how do I get the data into my travel sample scope? Couchbase makes this really easy. It's got an import feature. So I'm going to select my file, which was ishmaels.csv. I'm going to parse it as CSV, and I'm going to put it into the inventory coffee scope. Now you'll see Couchbase is smart. He's already gone out and done his best to parse this thing out and turn it into nice JSON. So see, it's going to have an ID and a longitude and a latitude, a shop name, and some kind of a string which describes the address. Now, by default, Couchbase will go out and generate a unique ID, but if we know that we have an ID in the data, we can go ahead and use that one instead. And that's what I'm going to do. I'm going to use the ID field. So click import, boom, 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 boom. And you'll see that Couchbase has gone and added that data to my database. And if I take a look at that, I'll see in my coffee scope, coffee collection within the inventory scope, that I've got documents that describe exactly what I imported. Now, those of you who are paying really close attention will notice that I no longer have a little field called lat and another little field called long. I've converted that to a little geo array. How did I do that? I did a little behind the scenes stuff before I started, and I had a convert function in Couchbase eventing. And all that thing did was say, okay, let's take every doc that comes in, let's go ahead and create a brand new address string field and a new field, which is an array called loc. I'm going to push the longitude and the latitude in that order. That's important, as we will discover as we go further along, into my array. And I'm going to go ahead and, because I hated those underscores within my address string, replace those with commas, and then push those to a new doc. Now, the new doc is going to have the same ID as the old doc, which is another way of saying it's going to replace all those documents. So that's how I end up with a nice document that looks like exactly what I want. All right, so that's half of the problem, right? I've got my data that describes my coffee shops. Now, my second problem is, okay, what's the airport look like? Now, it turns out there's a lot of data out on the web in GeoJSON format. If you start Googling for shape files or GeoJSON files for various things that you want, they're everywhere. And a GeoJSON file in its raw form looks like this. It's kind of hard to read. Let's go ahead and prettify that guy real quick to make it a little easier. And you'll see it looks like one enormous object that has a type called feature collection. And within that single object is a whole bunch of features, each of which describes the geometry of our individual airports. So, and then I get to describe the geometry name and give me some properties, including what the airport name is and all the rest. So there's a couple of things that I need to think about here, first of all. Number one is I don't want to import this as a single big, huge document because it's going to be hard to work with. I've got hundreds of airports here. I probably want to create hundreds of documents. A couple different ways that I can do that. I could go out and say, all right, let's just take and turn this thing into some kind of just an array by deleting this here and then going to the bottom of the doc and deleting that. And then I'd have an array of arrays, and that's ugly because number one, I'm doing it in an editor, which means that I'm limited to the size of what my editor is capable of doing. And number two, no guarantee that I'm doing it right. So we're going to use a tool called JQ, an online tool, in order to do this conversion of our document. And let's just go here. To use JQ, first of all, I can just cat the doc. I'm cutting and pasting here so you can be spared my typos. So there we go. I pipe it to JQ, and JQ immediately converts it into easy to read JSON. Now, what I want to find out is, am I really talking about a single object here or not? So I'm going to pipe that to tell me to look at that single type field. If I've got one object, I should only get one hit coming out of this. And sure enough, I've got a single type in that one object. It's called feature collection. Well, what does that mean? That means instead of accessing the type, I can access these features. Now I've got an array of features. Each one of those can then be treated as an individual document in Couchbase. So I'm just going to push those guys. I'm going to minify them. And I'm going to push those guys into a document. undis.json. Okay. Now I've got myself a whole new document that I can then use to import into Couchbase. And I could import that from the GUI, but I've already shown you that trick. So let's do it from the command line because that's available to you as well. What this looks like, and you can read it as use CB import, you're importing JSON, you're in a format of list. Now there's two types of formats. There's a format of list, which is to say your document is an array of multiple JSON elements that are going to each be treated as its own object. Or there's a format called lines. Lines means I've got a single line with a carriage return after each one, and that describes each of my JSON objects that I'm sending to my document. This is a format of list. Here are my credentials for my server. And the only thing I need to then tell it is where does the file live? It's called boundaries.json. What scope and collection am I putting it into? I'm putting it into my inventory scope, my boundaries collection, and the G stands for generate a key. I could generate a UUID again, or I can go out and specifically use one of the properties within that JSON file. So I'm using airport ID. That's perfectly acceptable ID. And you'll come back and see, yeah, boom, 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 21 documents imported, or sorry, 221 documents imported. So I've got all of my documents imported into Couchbase. And if I actually take a look at that and I look at my boundaries, you'll see here's one here. Here's for Baker Airport. Here's its ID. Here's its coordinates. It's a pretty small airport. It's only got, what, 6 vertices, 7 vertices describing it. Some of them have hundreds. It's in San Bernardino County, and here's what it looks like. So we've imported our data. So now I've imported my data for my coffee shops. I've imported my data for my airport boundaries. So we're actually through our data sources and acquisition. Next step, we're going to build a full text search index. This is really easy. You guys are going to like this. So all I'm going to do is go over to the full text search tab, and I'm going to say quick index. Quick index is great, right? Because I can just create an index. We'll call it coffee index, and from travel sample. And this is cool. Whatever collection you give it, it immediately tries to parse it out, and in fact does parse it out and tell you about what the fields are. I'm coming from my coffee. So I want to index one field. All I got to do is click on that field. It now adds it to my index. I can tell it what the type is. The type is GeoPoint. Now, remember when I told you it was important to put longitude before latitude in your little array here? The reason is because that is the convention for GeoPoints, not just in Couchbase, but in the world, in GeoJSON files and everywhere else. So if you're going to create a GeoPoint, remember to longitude, latitude is your order. So we just click add. That's the only thing I'm putting in my index. So I create index, boom, 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 boom. You'll see in a second that I've got myself a brand new index. And now I can actually start doing some cool stuff with my index. And we're going to do that from a couple different places. First of all, let's just get the, sorry, I can't talk and cut and paste at the same time. It's very sad. But let's just get what the center point is of LAX. So I run that, and I've got a latitude of 33.94 and a longitude of 118.400, et cetera. So if I want to then do a point and radius query to determine everything that fits within that area, I'm going to show you a couple of different ways to test it. You can test it straight from a curl. What that says is, okay, for this server, for this index, that coffee IDX that we just created, run a query against this location for a distance of 2-mile radius. Give me everything that fits in, and the field that you're going to use to find those points is called loc. JQ just makes it pretty on the output. So look at that. I found myself 6 results of airports that are of coffee shops that are around my airport, and if all I cared about was that, I'd be done. But of course, we have more cool things to do. So that's not all we care about. And here's the reason why. If I look at my 6 coffee shops that came up, this is a big problem. This looks like the closest one, but I can't actually get in there and buy a cup of coffee, right? Because it's behind the terminal gates and through security, and I just went and got my car. So I need to have a better way of describing where I want to search for my coffee shops. Now, one way I could do this is using what they call a boundary box query. Now, a boundary box query, you can think of as maybe starting here and drawing a line that goes across Westchester Boulevard and then down La Cienega and across Century and all the way up here to the Pacific. It's a square that describes what your airport boundaries are. And we actually have boundary boxes defined in our database as well, as you'll see. Let's look at an example of that real quick. If I go out and do this query, I can pass it a boundary box and it'll come back and tell you. Now, you have to be careful when you're doing a boundary box query, and the reason is because you don't always find these GeoJSONs being very polite about telling you which is which. You need to be upper left, lower right when you pass it to your query. And your query is going to look like this. Okay. Passing it my boundary box. There we go. It's a little easier to read. Passing it my top left and my bottom right. Again, I'm using the location field, and it's going to return me 4 things that made the cut there. So what's the problem there? Well, again, if I look at that, if it gave me 4, why? It eliminated all these guys. They were within my square. So boundary box isn't always a great way for you to go and do your geospatial search. However, it's really easy. In fact, you can do it if you wanted to see that from a query within Couchbase instead of from, well, within the query. It's all Couchbase, but within the query editor, you can do it this way. This is that same query that I had in the curl, right? The same query, bottom left, or top left, bottom right, and I'm going to get the same sort of results. I'm going to get 4. Now, what I really want to do is I want to give me everybody that's not in this boundary box, but is within that circle of nearby coffee shops. And we have a way to do that, and it's called a disjunct query. Now, a disjunct is just essentially a logical, even Boolean. You can think of it as a Boolean thing, because what you're doing, oops, let's not do that twice, or that's going to be a problem. There we go. I'm saying, give me everything that is within my 2-mile circle, but exclude anything that is within the boundaries, the simple boundaries of the airport. And if I run that, I knew I was copying that code wrong. Sorry, guys. Let's do it again. Oh, see how I spelled select? L-E. Think that'll help. Ah, yes. Okay, so now I've only got 2 shops that fit within my boundary. Why? Because I said, give me everything within the circle, but exclude everything within the square. I still kind of hate that, right? Because I'm not getting access to my 2 close cups of coffee right here on Century Boulevard. So that's not a perfect solution either. The real solution, if I want to really solve this problem, is going to be what they called a polygonal search, right? I've got a fairly complicated polygon with a whole bunch of different vertices that describe the airport boundaries. Now, if I do that same disjunct query that I just did a moment ago, but this time do it with the polygon, which I will show you here. Okay, now I got a 774 line query. It's getting a little silly, but it does give me my answer, right? Because it's going to say, give me everything that's within this 2-mile radius, but not within the confines of this complicatedly described polygon. So let's execute that. And there we go. Success. I've got 5 coffee shops that meet my criteria. Nothing but those 5 coffee shops. So life is pretty good. The only problem is, well, I can't really tell my application developers to go and cut and paste thousands of lines of polygon vertices every time somebody clicks, I want this coffee shop on their phone. We have a solution for this, and it involves using something called common table expressions. Now, common table expressions are a way for you to go out and use things that have been retrieved from the database, in this case, from the boundaries part of our database, and treat them as a simple object that you can pass to another query. So let's show you what I mean by that. If I start out with a query that looks like this, we'll start with the easy one first, which is the location. So I'm going to just go out and say, select everything from my LAX. This gives me my latitude and my longitude for my airport. Well, we don't really just want latitude and longitude. We want this to be geo.lon, geo.lat. I don't need all this other junk. Okay, but I also need to turn that into an array. So I've got a nice array, put this into a brand new array, and we'll close that off. And if I run that, well, now I've got a nice array. I've got an array that's called $1, which I'm not completely happy with. So let's pass that as a raw. Now I've got something that allows me to pass exactly what I want to my query, which we're going to do in a moment. So let's look at this as a finishing point. Same thing I just showed you, it's just I'm now assigning it a name of location. And I'm saying, give me only the first element of these interrelated arrays that came out and call it location. So whenever I say, give me location, just pass me back this array. So kind of put a pin in that and remember what that feels like, because we're going to use that in a moment. But before we do, I want to also be able to go get something called a polygon that I'm going to use instead of cutting and pasting all those vertices. So the way we're going to do that, let's just start with simple query. I got all kinds of stuff here. I don't really want anything from here except the geometry.coordinates, right? Yeah, so now I've got my coordinates. And again, this is the same thing. It's embedded in a quadruple array here. Well, I don't want all that stuff. So let's flatten it down a couple levels. And the way you do that is exactly what you think. And we're going to flatten it down 2 levels. Hope that I spelled it right. Oh yeah, look at that. All right, then we're going to select that raw, because that gives it to me without the funny numbers. Now I've got almost everything that I want. And again, I'll spare you watching me do the final typing here to show you what the test looks like. Okay, so now I have a polygon, which is defined as selecting all this stuff with the query we just defined and only taking the first element of the array. And I have a thing called an object called polygon, which is really an array of coordinates, which is exactly what I want. So you remember all these things that we've done here. Let's go back now and look at that query. Remember here in my history, we had this big long query that passed it all kinds of coordinates. There we go. Close that. Remember this guy? Well, that's a lot, and that's what we're trying to avoid. So let's take the cool things that we just learned and let's put them into our query and use them. We're going to take 2 width statements. So I got 2 common table expressions. Widths are always, if you've got multiple ones, you separate them with a comma. So I've got 2 objects that I've defined. One's called location and one's called polygon. Location, instead of having to look this thing up, we're just going to pass it the location that it's looked up. This one's even better. I have this huge polygon, right? Let's just eliminate all this stuff all the way down to this last area. And let's just replace that with the word polygon. Polygon's defined here. Location's defined here. I pass them both to my query. I've gone from a 700-line query to a 30-line query. It gives me everything that I want. Last thing that I want to do in order to make this really simple for my application developers to use is I'm going to go ahead and do a quick prepare here. So we're going to say prepare. I think that would be easy to spell. Prepare q distance as, and we're going to parameterize this guy. So we're going to put in first parameter is this, Same first parameter here. And why don't we parameterize this too, just for fun? Okay. So now I've got a prepared query called QDistance. If I execute that, execute QDistance using LAX, 2 miles. All right, now I got something that I can pass directly to my application developers and they're in business, right? So let's try it out with San Diego. And maybe let's see what's in Palm Springs. Why not? 4 miles for Palm Springs. Okay, so you've got now a single line, you pass to your application developers, gives you everything you want, starting with nothing and ending up with a pretty decent little geo search application, all just leveraging the power of Couchbase. Okay, that's the end of this session. Last thing I want to say is thank you. I really appreciate you joining. Hope it was useful to you, and I hope you enjoy the rest of the sessions you attend at Couchbase Connect Online.